Hello everyone, so welcome back to the good stuff that I've been doing. Today in this video we're going to try to find the integral from 0 to 1 of log of x to the fourth power, all divided by 1 plus x to the second power dx. So to begin with, let's recognize that we can write 1 over 1 minus x to be the sum, to be 1 plus x, then plus x to the second, plus x to the third, and so on. So which means that 1 over 1 plus x should be 1 minus x plus x squared minus x to the third. And so therefore 1 over 1 plus x, we can write this as the sum of negative 1 to the n x to the n, as n runs from 1 up until, n runs from 0 up until infinity. So which means that if we change x to x squared, we'll have 1 over 1 plus x to be the sum as n runs from 0 to infinity of negative 1 to the n x to the 2n. This is done by changing x to x squared in this particular formula. So what we'll do next here is that we're going to try to see how we can relate this to our integral. The integral here is from 0 to 1 of log of x to the fourth power, all divided by 1 plus x squared. So let's leave this for now. So the formula we already found. Okay, there's a 2 here. The formula for 1 over 1 plus x squared, we're going to write this as this integral from 0 to 1 of log of x all to the fourth power. Then you are going to multiply this by the sum as n runs from 0 to infinity of negative 1 to the n x to the 2n dx. So we already converted this to a sum. Now we can obviously take the sum outside, interchange by Fubini's theorem. So we have this is equals to the sum as n runs from 0 to infinity of, then we will have the integral from 0 to 1 of log of x to the fourth power, and then x to the 2n dx. Now notice that here, one good trick you should recognize here is that when you take y, say y to be let's say x to the 2n, if you take dy over dx, you will end up with dy over dn. If you take dy over dn, you would end up with 2 logarithm of x, then x to the 2n. So if you take partial square y over partial n squared, you end up with 2 squared, then you have log x to the second power, then x to the 2n. And similarly, if you continue to take partial to the third power of fourth power of y, and then partial n to the fourth, you end up with 2 to the fourth power, then you have log of x to the fourth, then you have x to the 2n. So which tells you that x to the 2n, so that is logarithm of so that means if you divide by 1/4, you get that this logarithm of x to the fourth, like logarithm of x to the fourth power, is actually 1/4 of partial to the fourth of y partial n to the fourth of x to the 2n. So we can come here, back, and then what we'll do here is that we're going to, let's put a different color. So we're going to say this is equals to the sum to begin with as n runs from 0 up until infinity. Then we will have negative 1. Okay, I forgot this negative 1 to the n here. Okay, negative 1 to the n. Then you have partial to the fourth of y partial n to the fourth. So it's times 1 over 2 to the fourth, obviously. Then the integral from 0 to 1 of x to the 2n dx. Okay. So if we continue in this fashion, we'll end up with, this is the sum as n runs from 0 up until infinity of negative 1 to the n. Then you have, okay, let's say 1 over 2 to the fourth, of course. Then you have this. Now for this case, this integral alone is just this is partial to the fourth over partial n to the fourth of what? 1 over 2n plus 1. Okay, so now, and if we take derivative of this 4 times, I won't show the full working here, but let's say you decide to put this in red. Okay, so let's say you come to take derivative partial to the fourth of partial n to the fourth of 1 over 2n plus 1, you would end up with 2 to the 4 factorial. So 2 to the 4 times 4 factorial, all divided by 2n plus 1 to the 5th power. So which means we can put this back into our problem here. So this will be 1 over 2 to the 4th times the sum as n runs from 0 to infinity of negative 1 to the n. Then you will have 2 to the 4th times 4 factorial, all divided by 2n plus 1 to the 4th, to the 5th power rather, to the 5th power. Now, of course, this cancel out, and then so you have 4 factorial. This is 4 factorial multiplied by the sum as n runs from 0 to infinity of negative 1 to the n. Then you have 1 over, okay, let's just put it this way, negative 1 to the n, all divided by 2n plus 1 to the 5th power. Notice that the Dirichlet beta function, beta of x, is the sum as n runs from 0 to infinity of negative 1 to the n, 2n plus 1 to the s power. Now, beta of 5 actually is equals to, if you take mathematical, you would definitely get 5 by, let me check, be sure. You get 5 pi to the 5th power, all divided by 1536. So you get this. So in this case, this is equals to 4 factorial multiplied by 5 pi to the 4th power, all divided by 1536. And you would end up, if you do the math here, you end up with 5 pi to the 5th, all divided by 64. So that means that this integral here equals 5 pi to the 6th, all divided by 64, and that is all. So here we use the method of series to evaluate this integral. So thank you for watching, and please do have a nice day. Bye.